Welcome all. Today I am going to explain about my minor project topic, machine learning based flood prediction. My teammates are Praveen and Suchit, and the project is supervised by Dr. M. Shamla Devi. Next slide is agenda. It includes abstract, objective, introduction, literature review, design and methodologies, standards and policies used, implementation, testing, input and output, demo video, conclusion, future enhancements, web references link, references, plagiarism report, or PPT poster presentation. First slide is abstract. It includes the details about flood. Like flooding is the most common natural disaster on the planet, which is affecting hundreds of millions of people and causing between 6,000 and 18,000 fatalities every year, of which 20% are in India. Reliable early warning systems have been shown to prevent a significant fraction of fatalities and economic damage. But many people don't have access to those type of warning systems. So to avoid it, flood prediction system based on machine learning are built. This enhancement of this prediction system provides cost-effective solutions and better performance. In this, a prediction model is constructed using rainfall data to predict the occurrence of floods due to rainfall. The model predicts whether flood may happen or not based on the rainfall range for particular locations. Indian district rainfall data is used to build the prediction model. The data set is trained with various algorithms such as K nearest neighbors, XGBoost, and so on. Floods are one of the costliest and deadliest natural disasters known to mankind. Due to the inconsistent nature of rain, estimation of flood becomes complex. Next slide is objectives. Firstly, the aim of the project is to mimic the complex mathematical expressions of physical processes of floods. During the past 2 decades, machine learning methods contributed highly in the advancement of prediction systems, providing better performance and cost-effective solutions. And the scope of the project is that it will try to avoid floods by predicting it from before using machine learning techniques. If proper prediction of flood is done, then it much reduce the chance of happening floods in future, and it will avoid any disaster to occur. Machine learning algorithms can analyze large amount of data from various sources such as satellite imagery, weather forecast, river flow sensors. These models can be trained using supervised, unsupervised, or reinforcement learning techniques to predict flood events with a high degree of accuracy. Next slide is introduction. Every year, India is the topmost flood-prone disaster place in the world. Mostly waterlogging in urban cities occur in low-lying areas. Moreover, the increase in waterlogging is due to some fundamental points such as surface runoff, relative altitude, and not enough path of the water to drainage. So flood forecasting is essential at these places. In a recent year, there were many parts of countries which are prone to flood, like Assam, Bihar, Goa, Odisha, Pune, Maharashtra, Tamil Nadu, Karnataka, Kerala, and Gujarat. In the year 2015 rainfall, Chennai received 1049 millimeters of rainfall in November. Since 1918, 1088 millimeter of precipitation was best recorded in November. Among the natural disasters, floods are the most destructive, causing massive damage to human life, infrastructure, agriculture, and the socio-economic system. Governments, therefore, are under pressure to develop reliable and accurate maps of flood risk areas and further plan for sustainable flood risk management, focusing on prevention, protection, and preparedness. Flood prediction models are of significant importance for hazard assessment and extreme event management. Robust and accurate prediction contribute highly to water recourse management strategies, policy suggestions, and analysis, and further evacuation modeling. Thus, the importance of advanced systems for short term and long term prediction for flood and other hydrological events is strongly emphasized to alleviate damage. Next slide is regarding literature review. Here we have considered 5 papers. The first paper Is author is J. Akshaya and PLK Priyadarshini. They introduced a model like a hybrid machine learning approach for classifying aerial images of flood hit areas. It was introduced in 2019. So this paper addressed various issues occurring in numerous parts of southern India have recently encountered several damage to lives and properties due to floods. Floods are one among the most destructive natural hazards, and recovering to normal life takes ample time. During hazards, various technologies are in use for speeding up relief operations and to minimize the amount of damage. One such being the use of drones. The next paper is next. AB Ranit and PV Durga, they introduced different techniques of flood forecasting and their applications, and it was introduced in 2018. This paper addressed flood forecasting importance and its challenging problems in hydrology. Reliability of forecast is to provide as much advance notice as possible of an impending flood to the authorities and the general public. The third paper is F.A. Ruslan, K. Harun, A.M. Samad, and R. Adnan. They introduced multiple input, single output ARX and ARMX model of flood prediction system in 2017. This paper gives information about year and usually would see many states in Malaysia would probably hit by severe floods due to monsoon rain, especially in each coast. Next paper is about FRG Cruz, MG Binag, MRC GA, and FAUY. They introduced flood prediction using multi-layer artificial neural networks in monitoring system with rain gauge. It was introduced in 2018. This paper tells about flood, which is one of the most destructive natural phenomena that happens on most part of the world, notably in the Philippines. This was a major issue where it can lead to damage of properties, damage to infrastructure, or even loss of lives. Fifth paper is G. Kaur and A. Bala. They introduced an efficient automotive hybrid algorithm to predict floods in cloud environment. It was introduced in 2019. This paper tells about the natural environmental sciences are one of the scientific domains which seek a lot of attention as it requires accurate real-time predictions. Next slide is about design and methodologies. Here we have used four modules such as data pre-processing, feature extraction, model training, and a flood prediction. First module is data pre-processing. This pre-processing refers to cleaning of the data by removing the duplicates, filling in missing values, and normalizing the data. The goal of pre-processing is to transform the raw data into a format that can be used by machine learning algorithms to do proper prediction. Second module is feature extraction. It is a critical step in machine learning based flood prediction as it involves selecting and transforming relevant input variables into a more informative representation and can be used by the model to make accurate predictions. Third module is model training. For flood prediction is a complex process that involves gathering and cleaning data, choosing a machine learning algorithm and training the algorithm to predict floods. Module 4 is a flood prediction model that can generate a probability of flooding for a given area based on historical data. This can help communities prepare for potential floods by alerting them to the likelihood of flooding. Next slide. Next slide is standards and policies. Flood Modeler. Flood Modeler is a software for flood modeling and prediction developed by Jacobs. It has a command line interface that can be used to automate various tasks such as creating and running models, generating flood maps, and producing reports. It is a standard used by ISO IEC 27001. Delta FEWS. It is a flood early warning system. It is an open source web application for flood prediction and early warning developed by Dentaires. It is designated to provide real-time flood forecasting and monitoring and can be used to manage and analyze large volumes of data. Next slide is Next slide consists of implementation. It includes diagrams such as architecture diagram, data flow diagram, use case diagram, class diagram, activity diagram, sequence diagram, and ER diagram. The first diagram is a architecture diagram. This architecture diagram shows the architecture of a machine learning based flood prediction, which involves components such as data collection. In this stage, we will collect the information about various data set which we need to process, and we'll upload the rainfall data set or other data set. Data pre-processing. Once the data is collected, it must be cleaned and pre-processed to remove any errors. Third is feature extraction. Next, relevant features must be extracted from the pre-processed data set. Fourth is model training. With the pre-processed and feature extracted data in machine learning model is trained by using various machine learning models such as KNN, K nearest neighbor. Fourth is model evaluation. The performance of the trained model is evaluated using metrics like accuracy, precision. Last one is deployment. Once the model is deemed to be accurate and reliable, it can be deployed in real world setting. Now we'll move to UML diagrams. Diagram is data flow diagram. This figure shows the data flow diagram, which consists of various steps, such as collecting weather data is the first step in which we will collect the weather data in order to predict floods. Next, send data to central server. After that, check whether danger of flood there or not. If yes, ring alarm and display precaution for preventing flood. Otherwise, store data and again follow same procedure, that is collecting weather data and again sending to central server. Next diagram is use case diagram. This shows the use case diagram, which is a high level visual representation of the potential interaction between the users and a system. So in this diagram, the actors are user, community leader, and officers, and system administrator. The use cases are authentication, update flood incidents, view map data, etc. In this diagram, the community leader and system administrators will collect flood related queries, and then they will give reports about flood, whether it will occur or not, and they will collect details about the rainfall data set or other whichever needed. Next diagram is class diagram. Shows the This figure shows the class diagram, which are the main building blocks of object-oriented method. In this diagram, the various classes are input data set, data pre-processing, deep network, wide network, and then model training. And at last, rainfall and flood prediction. Here we will analyze all classes and we will collect data about different rainfall data set. And firstly, it will check the data set and then it will do pre-processing of data. Next diagram is activity diagram. Here in activity diagrams we'll try to see whether this flood will last for long term or short term. So firstly we'll start after predicting that rainfall count for every state or per state. We'll get some idea about whether this flood will be for long time or short time. After that, if that answer for this long term will be yes, means flood occurrence will be more. If that output is low, means then the flood occurrence will be less. So like this we'll be predicting flood based on the rainfall count. Next diagram is sequence diagram. This figure shows the sequence diagram, which is a type of interaction diagram because it describes how and in which order a group of objects works together. Firstly, user will request for weather report from the communication controller. Then report will be collected from weather station and the summarization of reports will happen. And after that, the dataset will be uploaded to server. Next, the acknowledgement of report will be sent to the user from the communication controller. Next, servers will send report to weather station and weather station will send report to communication controller. Finally, weather report will be provided to the user. Now, the last diagram is ER diagram. For predicting flood, major thing is we should know that humidity of soil and all. So firstly, we'll try to find the details about the soil type, whether it is much moist or not. If moisture is more, means that rainfall, that excess rainfall, it can't absorb. And then we'll try to check this land use ratio. Then we'll try to check the district, like in various district, what is the rainfall count, etc. Now we'll move to the next slide. Next slide is testing. It consists of different testing methods: unit testing, integration testing, functional testing, white box testing, black box testing. Unit testing. It involves the design of test cases that validate them the internal program's logic is functioning properly, and that program inputs produce valid outputs. All decision branches in internal code flow should be validated. Integration testing are designed to test integrated software components to determine if they actually run as one program. Testing is event driven and is more concerned with the basic outcome of screens or fields. Functional testing provides systematic demonstrations that functions tested are available as specified by the business and technical requirements, system documentation, and the user manuals. White box testing is a testing in which the software tester has knowledge of the inner workings, structure, and language of the software, or at least its purpose. Black box testing is a testing without any knowledge of the inner workings, structure, or language of the module being tested. Next slide is about input and output design. Input design. This figure shows the input design of the rainfall dataset for the various states. Based on the dataset, the rainfall will be predicted, and based on the rainfall ratio or content, flood prediction for the dataset will be done. The above inputs dataset contains information about various states and their rainfall ratio per every month. The above diagram contains information about Kerala rainfall count. At last, it is telling total annual rainfall count per state. Next figure shows the output design. This figure shows the output design of the flood prediction. That is, firstly, we should enter details about rainfall count for a pair of months, such as March to May, etc. For predicting flood, we'll first do model training and then check whether flood will occur or not. If it will occur, then the chance of occurring floods will be displayed with the accuracy. Otherwise, it is showing like there is no chance of occurring flood. Next slide contains of conclusion. We have successfully developed a system to predict whether the floods will occur or not. In this application, this is created in a user-friendly environment with Python programming and Flask. The system is likely to gather data from the user in order to predict whether there is a chance of flood occurring or not. In conclusion, machine learning based flood prediction has the potential to revolutionize the way we prepare for and respond to floods. By analyzing vast amounts of historical and real time data from weather sensors, river gauges, and other sources, machine learning algorithms can help to identify patterns and trends that can be used to predict when and where floods are likely to occur. The use of machine learning can also enable more accurate and timely predictions, which can be crucial in minimizing the damage caused by floods. Next slide is future enhancements. Like what this project will be doing in future. Machine learning based flood prediction models have already shown significant progress in predicting floods and providing early warnings to communities. However, there are several potential enhancements that can be made to these models in the future. One such enhancement is the incorporation of more data sources, such as social media data, which can provide real time information about flood conditions and help improve the accuracy of the models. Another enhancement could be the integration of artificial intelligence algorithms that can continuously learn and adapt to new data, improving the model's predictive capabilities over time. We intend to investigate prediction approach with the revised data set and employ the most accurate and relevant machine learning algorithms for detection. Next slide is references. These are the 5 references based on IEEE format which we selected for this project. Already these were explained in the literature review. Next slide consists of plagiarism report. In this report, we analyzed our main PPT and we got to know that only in this PPT 13% plagiarized content is there and 87% unique content is there. Next slide contains of poster presentation. This is the poster presentation of all the details which we have captured for this project. It is a short term, like it is a concise way of information. Here we included abstract, team members details, introduction, methodologies, results, then the output design, standards, policies, conclusions, and finally the acknowledgement to our supervisor. Now we'll move to the implementation of the project.
This is the source code of the project. We written the code in the Flask. Here I am going to show the web pages code. This is the front end code for the front page, that is index, and here the model HTML page and the production HTML page, and here the upload HTML page. Upload HTML page is nothing but we have to upload the flex data to predict the output. This is the HTML code for the view page. Now I'm going to run the code. Entering the command python app.py, we can run the code. After running this code, we'll get one web server. By clicking on it, first we'll get into our project home page. Welcome to flood protection detector. After that, we have to upload the files. Here we have to upload the file. That file is nothing but the our flood data file. File machine should be in the CSV format. Here I uploaded the CSV data file. This is the data which consists of the file. And now here coming to the model, we are implemented the using the four training models. First is the KNN and decision tree classifier, logistic regression, and XGBoost classifier. First we are going to train the model by using the KNN, that is k nearest neighbors. Now the accuracy of KNN is 0.98. Now we are going to predict the floods. There is no chance of occurring floods. This is the output.